Okay, so we've talked about speed and velocity. Now we're going to talk about acceleration. So what is acceleration? Well, recall that speed is the rate of change of position, or how fast you change places, right? Well, acceleration is how fast you change speed, or how much you speed up or slow down. So if it is actually how fast you change velocity and not speed, what does that also mean it has? Here's your hint. It's direction, right? So here's some hints about acceleration. Because velocity includes speed and direction of the object, acceleration is also going to be a change in how fast the object is moving and what direction the object is moving. And acceleration is going to occur when the object is changing speed, or when the object is changing direction, or both. Okay? So, speeding up or slowing down. So, when an object speeds up, that's considered positive acceleration. When a car slows down, that's considered negative acceleration, or sometimes you might hear that referred to as deceleration. That's probably the term that you would use. Here's the acceleration formula. Here is it in words in a couple different ways. So you have acceleration equals the change in velocity over time. And here's how we would say that. We would say acceleration equals the final velocity, so the velocity that you're traveling at the end. And that's going to be minus the initial velocity, so the velocity you're traveling at the beginning divided by time. And here is the equation in short version. Okay, so final velocity we say is v with a little f, initial velocity v a little I, and then t for time. Okay, and then a is obviously acceleration. So if we rearrange that equation, we can do this just like we did when we had the speed equation or the velocity equation. We can put the acceleration over 1 and we can cross multiply. So say we are wanting to solve for one of the velocities, right? So we could say a times t equals the velocities. So you could do, if you were solving for final velocity, you could do final velocity minus initial velocity equals a times t. Or, you know, the other one. And then you just subtract or add the other one. If you were looking for time, then, you know, if you were looking for this one, you would just divide by a to get rid of it, right? So this is the equation for t, or if you were looking for this one, it's a times t, okay? So it's going to be the same all year long. Acceleration units, you're always going to have something like this. So this would be 5m/s2. So the way you would read it would be 5 meters per second squared. And what this means is that for every second that goes by, you're going to speed up 5 meters per second. So after 1 second, you're going to be going 5 meters per second. After 2 seconds, you'll be going 10 meters per second. After 3 seconds, you're going to be going 15 meters per second. Does that make sense? Okay. You could have different acceleration units. You could have 5 kilometers per minute, or kilometers per hour per second, or something like that. Okay, so here's an example problem. A motorcycle starts at rest and accelerates to 80 meters per second in 20 seconds. So let's take a look at a couple things here. The first thing I want to take a look at is if you're starting at rest. What does that mean? Okay. So first of all, we got to take a look at the language here. If you're starting, that's going to be your initial velocity, right? And at rest means you're going 0. So your initial velocity is 0. And you're going to accelerate to. That means you're going to end up going this fast. Your final velocity is 80 meters per second. And then your time is 20 seconds. Okay. And I guess I cut off part of the question. So the question then asks, what is the acceleration? Okay, so we're looking for the acceleration. Okay. And our units are going to be meters per second squared. And I know that because my speed's measured in meters per second, and then my time's measured in seconds as well. Equation for acceleration, we just learned this, is final velocity minus initial velocity over time. So my final velocity is 80, my initial velocity is 0, and my time is 20. So 80 divided by 20 is 4, right? 4 meters per second squared. Which means, sounds very good too, there, every second I speed up 4 meters per second. Okay? Okay, so let's take a look at this graph. So it says velocity versus time graph, and we're going to look at the acceleration. So we have velocity here, and we have time here. This is your x-axis, this is your y. This one looks just a little funny because we have a negative value, but it's just like anything you've seen. The important thing here is, and we had these on your last video, but this is just a refresher really quickly. If you have a horizontal line here, recall that that is going to be a constant speed. And if you have an increasing slope, an upward slope line, that is an increasing speed. Okay? So let's do another example here. It says a skateboarder moves in a straight line at 3 meters per second and comes to a stop. Okay, so let's find our acceleration. So, for our initial velocity, this time is 3 meters per second, and our final velocity is stopped, right? So that would be 0 this time. So the big part here is reading the problems and figuring out what they're saying. So resting, stopping, that's all 0, right? And then 2 seconds is my time. So time is 2 here. So my unknown is my acceleration. And this time, again, it's going to be meters per second squared because my speed's measured in meters per second and my acceleration's measured in meters per second. So VF minus VI over T. So we have 0 minus 3 over 2. So in this case, notice the top is negative. So we have 0 minus 3. And that's going to be a negative number. And some of you might be thinking, well, that can't be right? We can't have a negative number. But you can have a negative number. And that would be completely okay. Okay? So if you get a negative number in acceleration problem, just check to make sure you did it right. And if you did, then you're fine. You will have negative. And remember, that means you slowed down. Negative acceleration means you slowed down. And we did slow down. We went from 3 to 0. So negative 3 divided by 2 is negative 1.5. Okay, negative 1.5, and that's meters per second squared. Okay, so we're going to look at one more thing. We're going to look at one more graph. And so here we have another velocity versus time graph. And remember again that this horizontal line equals a constant speed. And then this time I just want to make sure you remember, if you have a decreasing slope or a downward slope, that is a decreasing speed. Okay?